Alright, let's look at the next circuit. Here we have 3 resistors in series, just like a TV series, they're one after each other, and they're connected to an 18 volt supply. We have an 18 volt line or rail, we have a 0 volt, okay, just the same as it would be a battery or a cell, doesn't matter. We've got 18 volts here and 0 volts here. We have 3 resistors in series. We also have an ammeter, because the ammeter will only work by being in series with the component. So that ammeter will be the total current of this whole circuit. So let's say we want to find the voltage over one of these resistors. Now, why would we want to do that? Potentially we could use this as a voltage divider, okay, where we would have 18 volts, 0 volts, and we maybe want 6 volts out to feed a component, or maybe want 2 volts out to feed a component. Okay, so let's just imagine we're wanting the voltage out, and how could we calculate this, what the actual voltage would be? Well, first of all, we need to figure out our current. Now if we look at our wee triangle, it's V equals I times R. We know what V is, we know what R is, so we want to find I. Or do we know what R is? In order to find the total, or the series, we need to add all these resistors up to give us R. So we have 10 kilo ohms, 6 kilo ohms, 2 kilo ohms, so that gives us 18,000 ohms. So the total resistance in this series is 18,000 ohms. Now, the reason we just add them up is because that's what the formula is for resistors in series. We just simply add them up. Okay, so we know what R is now. So we have our formula, V equals I times R. We know V is 18 volts. We know R is 18,000. Let's find I. So what would I be? Well, it would be 18 divided by 18,000. That gives us 0.001. If we move the decimal place a few, it would give us 1 milliamp. Let's activate the circuit, and here you can see the ammeter reads 1 milliamp. So the theory, alright, is endorsed by actual practice using the software. So the current going through this circuit is 1 milliamp. So what would the voltage be across, let's say, the 6 kilo ohm resistor here? What would the voltage be? Well, we'll obviously get a wee voltmeter. We'll bring it across. So once we do the calculator, we can actually show you it working. Alright. So it's a simple of V equals I times R. We know I is 1 milliamp, or 0.001. And we know R is 6,000. So it would be 0.001 times 6,000, because remember it's ohms, equals 6. So we know the voltage across this resistor is 6 volts. So if we needed 6 volts off of this, we could take 2 cables and attach them to whatever we needed. Alright, in this case the 2 cables are just going to an ammeter. I don't know why it's going to an ammeter, it should be a voltmeter. Let's change that. Let's change that to a voltmeter. Don't know why. I did an ammeter there. There we go, a voltmeter. Alright, so we've just worked that out as 6. Let's test it. And here you can see the actual circuit shows that it is 6 volts. So let's do another one. Let's say we want the voltage out over this point here. Well, let's get a voltmeter. Let's connect it. Okay, let's connect it here. We know the current is 0.001, because that doesn't change throughout the full circuit, so it's 0.001 times 2000, because it's 2000 ohms, equals 2. So if we activate this circuit, you'll see that this is 2. So let's do the top one, last final one. Let's bring a voltmeter in. connect up to the circuit, just like that, and it'll be the same again, 0.001 because the current doesn't change, times 10,000 because it's 10,000 ohms equals 10. So if we play it, we can see that that's 10. The other thing to note here is that these resistor values are relative to the voltage. So here we've got 18 volts and here we've got 18,000. So you could say that for every 1000 ohms is 1 volt. So it's 2 kilo ohms is 2 volts, 6 kilo ohms is 6 volts, 10 kilo ohms is 10 volts. Alright, and that's actually an easy way to do it if they're proportionate. Alright, if there's two resistors here, each valued at 9, for example, or say there are two resistors here valued at 100, alright, then each one would be half, because it's proportionate. Alright, so you could add the total resistance up, divide that into the volts, and you'll get a voltage value per ohm, and then you can multiply that by the actual resistor value. That is another way to do it. However, we've just done the V equals IR. It's very simple. If you're learning your studies and you only want to remember the one formula, then this is how you use it, using V equals IR formula. Okay, you work out the current first, and then you just do it individually across each resistor. Alright, let's say we want a resistor value, or sorry, a voltmeter reading off, say, 2 of them, say there, then you'll see that that's 8 volts. And the key is here, there can't be any spare volts. All the voltage must add up to 18. Alright, so we've obviously got the 6 and the 2, and we worked them out previously, it's 6 volts and 2 volts, so that's a total of 8 volts. There can't be any spare voltage, alright? And that's how we work out the voltage across resistors in series, which can be used as a voltage divider.